always blocks. So what we have seen so far in here is we specifically use HDL to describe the structure of each of the circuits we have built so far. All the multiplexers here, we really structurally did describe them. So first we described the structure of the 2x1, then we described the structure of how we're using them. Everything is structural here. So always statement, on the other hand, allows us to code or allows us to generate a circuit by describing their behavior. So the previous style of coding is called a structural description, and now we're introducing always blocks, which actually allows us to do behavioral description of the circuit. Okay, so again, like any of the other modules we have seen, you have to put the ports, you have to see internal signals, and then you have an always block in here. And in the always block, usually it takes a sensitivity list, and the sensitivity list tells it what are the inputs to this particular always statement, and any change in any one of these inputs will actually trigger the always statement and will actually go in and execute whatever expressions are in it. These expressions here are considered not continuous assignment. They're called procedural assignment, and there's a couple of types of them, which are blocking and non-blocking, and I'll show you these in a minute. So what I have done here is I actually started the always statement, and then I basically just moved the continuous assignment inside, nothing else. Of course, there's other ways to actually describe this multiplexers. For example, you can describe it with an if statement or a case statement. There are many ways to describe that behavior, not a single one, but this actually also works. The reason I'm introducing always blocks now and I'm pausing on them and it's like spending a little bit of time on them because System Verilog introduces new always blocks. So the previous always block, you always had to specify your sensitivity list, for example, in here, and if you missed the S or the X1, your code would not work, and there's a lot of things involved in here. So System Verilog introduces three additional always block. It supports the older one because it supports Verilog 2001. So whatever you wrote in Verilog should work here just fine. But this I find a little bit easier and a little bit more robust. Your code will be a little bit more robust and a little bit less error prone. So an always comb, as the name implies, is for combinational circuit. You can basically specify within this always statement, I'm writing a combinational circuit. And always FF will push Vivado to infer a flip-flop. So usually when you're dealing with sequential circuit, I would use that. And this one here is actually would force it to use a latch. In this course, you're going to see me using always comb with combinational and always FF with sequential circuits like counters and registers. Why would I need additional ones? Well, you would need an always comb because it's very interesting that sometimes you write some code, it's for combinational circuit, and because your code is a little bit, has an error, not necessarily a syntactic error, but a logical error, and it actually generates something which is basically a latch. Well, a combinational circuit should not have a latch. Let's assume that it's a D latch or a D flip-flop for that matter. It's either or. It's a memory element, where a combinational circuit should not have a memory element in it. What you're going to see is Vivado is going to throw a warning telling you, hey, there's something with your code and you're designing a combinational circuit, but unfortunately it's inferring some memory element, so you need to fix the code and figure out what to do with that. So this is actually nice, and that's why I would use it. Of course, there are other benefits to it too. For example, let me. For example, in an always comb, you do not have to specify the sensitivity list anymore. It will know exactly, well, these are the inputs, so I'm just going to put it. So you will avoid the error of, well, forgetting an S or forgetting an X1 and 1 out. Okay, so let me rewrite that code again using an always comp. It's pretty much the same code. I just removed the sensitivity list and I just put a comp in here, and I'll just run it. You can use it in exactly the same way you have used always blocks before. It's just a little bit more robust in here. And you can see when we deal with if statement or cases that sometimes you need certain consideration with if statements and cases and case, not switches. They're not called switches here, but case, for example, case S and whatnot. There are certain situations in here where it will infer a memory element, and you will get a warning if you use always comp in here. All right. So procedural assignments, I'm just gonna basically just talk very briefly about it. There's a separate video that explains them in detail. So procedural assignment are different than continuous assignment. We have a couple of them. We have blocking assignment, and this actually is indicated by an equal sign. So what happens, I have a left-hand side and a right-hand side, and what happens is the right-hand side will get evaluated. For example, this OR gets evaluated, and then we call it immediate because it immediately assigns that value to the left-hand side, which is F in this case, and it will block everything afterwards, meaning it will not execute anything after this statement until this assignment from the right hand side to the left hand side is done. It blocks the secondary or the following expressions. It blocks it. So first it immediately assigns the right hand side to the left hand side, and it blocks everything else. So this is sequential. So if you, and again, you can only use it within always blocks, whether it's always combinational or always FF. So the non-blocking assignment, on the other hand, has a greater than or less than and equality sign in here. And what happens is it's called a non-blocking assignment because what happens is the right-hand side gets evaluated, but it doesn't get assigned to F immediately. It gets deferred to the very end of the always block, and at that point, it actually assigns it. So this is called a non-blocking. Generally speaking, we use blocking assignments with combinational circuits and non-blocking assignment with sequential circuits. And there are certain coding styles. So the way they work is explained in a separate video, but there are certain coding styles that even if you do not understand how they work and you follow these coding styles, you will, for sure, you will get working code 90% or 99% of the time.